Hello students, today we are going to discuss about simple harmonic motion. Before studying simple harmonic motion, let's understand what is periodic or harmonic motion, what is oscillatory and vibratory motion, and what is then simple harmonic motion. What is periodic motion? As the name indicates, periodic motion, harmonic motion, a motion that repeats itself in a definite time interval. A motion that repeats itself in a definite time interval is called periodic or harmonic motion. For example, suppose see the motion of this ball. In this ball, and the surface is smooth, the ball will move from here to here, here to here, here to here, and then here to here. This will perform periodic motion. See here. This is sun and this is earth. This is an example of periodic motion, okay? Means what? Now you can understand what is periodic motion. Any motion that repeats itself in a definite time interval is called periodic motion, okay? Now let's see about the oscillatory or vibratory motion. It is a special case of periodic motion. Which takes place to and fro about a fixed point. The motion of this spring pendulum in vertical plane. It is a oscillatory or vibratory motion. Any motion that takes place to and fro about a fixed point is called oscillatory or vibratory motion. Now, let us discuss simple harmonic motion. Simple harmonic motion. All simple harmonic motion are oscillatory or vibratory motion. All oscillatory or vibratory motion are periodic motion, okay? A motion is said to be a simple harmonic motion when restoring force is directly proportional to displacement from mean position and always directed towards mean position. And in angular SHM, the restoring torque is directly proportional to angular displacement and always directed towards mean position, okay? That is the general concept of the simple harmonic motion. Before studying simple harmonic motion, let's understand some important definitions. Let us say this is the equilibrium position. This is right extreme point and this is left extreme point. First, we will understand what is amplitude, which is denoted by letter A. Maximum displacement of particle from mean position is known as amplitude. Maximum displacement of particle from mean position is called amplitude, okay? So, this is called A, okay? Now, what is mean position? Means equilibrium position. Mean position is the position where force acting on the particle is zero. Means acceleration is zero. Means velocity is maximum. Or you can say at this situation kinetic energy is maximum and potential energy is minimum. These are the cases refers to the mean position. Okay. Now what about extreme position? What about extreme position? Extreme position is a position where kinetic energy is zero, where potential energy is maximum, or potential energy is equal to total energy in SHM. Okay. And what is phase? The phase of a particle indicates its position as well as direction of motion. The phase of a particle indicates its position as well as direction of motion. Okay. Dear student, now we are studying, we are looking for the simple case, simplest case of simple harmonic motion. Okay. What is the equation of simple harmonic motion? A simple harmonic motion, a simple harmonic motion is the motion of projection. Is the motion of projection on circle diameter performing uniform circular motion. Let's listen once again. A simple harmonic motion is a motion of projection of particle performing uniform circular motion. Okay. Now let us see. If the particle starts its journey from point P, then P to Q, then Q to R, and then R to S. And let us see, the radius of the circle is capital A. Okay. And this is the position of the projection. Now see, this is the particle position. And this is the projection position. Now particle is moving from P to Q, Q to R, R to S, then S to P. And the projection is moving from O, O to Q, and then Q to O, O to S, and S to O. This is the motion of projection. Okay. So here is time T by 4, capital T is time period. This is also T by 4, this is also T by 4, this is also T by 4. What is time period? Time taken by a particle in one revolution is called time period. In one period is called time period. Okay. So dear student, let's see once again the definition of time period in SHM. Suppose this is mean position, this is right extreme, and this is left extreme. So if particle is moving from mean position to right extreme to mean position, then mean position to left extreme, then left extreme to mean position. This is what? This is equal to time period. Okay. Or you can say, if particle is moving from left extreme to O, O to P, P to O, and then O to Q. Left extreme to right extreme, and then right extreme to left extreme, this is also time period. Or particle is moving from right extreme to O, O to Q, Q to O, and then O to P. Right extreme to left extreme and left extreme to right extreme, this is also time period. Okay. But always remember, time period cannot be general way classified as moving from particular position to particular position. Time period can be from moving from particular position to particular position. If the particular position is either left extreme or right extreme, then only we can say then this is a time period. Listen once again. If the particle is moving from left extreme to right extreme and right extreme to left extreme, then it is time period. When a particle moves from left extreme to right extreme and then returns back from right extreme to left extreme, then it is called time period. Okay. Or right extreme to left extreme and left extreme to right extreme, that is also time period. But dear student, moving from mean position to right extreme and then right extreme to mean position, this is not time period. This is half of the time period. Okay. So hope you understood the definition of time period. Now let's see the simplest equation of particle performing SHM. Let us assume particle starts from point P. This is at t equal to 0. Now at t equal to t, the particle has traveled angle theta. And this is a circular path having radius capital A. So this is what x. X equal to what? This is A sin theta. And since this is the projection of particle performing uniform circular motion, so we can write x equal to A sin theta. And theta can be written as A sin omega t. This is the simplest equation of SHM with initial phase 0. This is the simplest equation of SHM with initial phase 0. Okay. Now, if we differentiate the equation, we will get velocity. Okay, v equal to dx upon dt. And again, if we differentiate velocity with respect to time, we will get acceleration, a equal to dv upon dt. So let's see the differentiation. V equal to what? Dx upon dt. This is what? A omega cos omega t. This equation can be written as a omega sin omega t plus pi by 2. Now you can see the phase of displacement is omega t, phase of velocity is omega t plus pi by 2, means phase difference between velocity and displacement. Phase difference between velocity and displacement is pi by 2. Okay, this is the first relation. And second relation, we can write this v equal to a omega cos omega t like this. V equal to a omega cos omega t can be written as under root 1 minus sin square omega t. And sin omega t can be written as x upon a. So if we substitute this relation, we will find v equal to omega root a square minus x square. This is the general relation between v, omega, a and x. From this relation, you can see at x equal to 0, which is mean position, okay, velocity of the particle is maximum performing SHM. This is equal to a omega. And omega can be written as 2 pi f, okay. And at x equal to a, that is extreme position where velocity is minimum, this is equal to 0, okay. At any position x from mean position, you can use this relation v equal to a omega root a square minus x square. And in term of time, if you want to write any equation, you can write v equal to a omega cos omega t. Dear student, if you make the differentiation of velocity with respect to time, you will get acceleration. So let's do. What is acceleration? Acceleration can be written as dv upon dt. And what is v? V is a omega cos omega t. So dear student, if we make the differentiation, we will find this is a omega minus omega sin omega t. This equation can be written as either omega square a sin omega t minus, or this equation can be written as minus omega square x, or this equation can be written as omega square a sin omega t plus pi. So these two relations are very important in SHM. Dear student, first relation is A proportional minus X. This is the general concept of SHM. In SHM, acceleration of particle is directly proportional to displacement from mean position and always directed towards mean position. In SHM, in simple harmonic motion, acceleration of particle is directly proportional to displacement from mean position and always directed towards mean position, okay. And one more thing, the phase difference, the phase of acceleration is omega t plus pi, okay. And the phase of velocity is what? Omega t plus pi by 2. And the phase of displacement is omega t. So dear student, in SHM, phase difference between acceleration and velocity is pi by 2. Phase difference between acceleration and displacement is pi. And phase difference between acceleration and displacement is pi, okay. between acceleration and velocity is pi by 2, between velocity and displacement is also pi by 2, between acceleration and displacement is pi. Okay, so this is the general relations. Okay, now you can solve some question. Amplitude of harmonic oscillator is A. When velocity of particle is half of maximum velocity, then position of particle will be. Dear student, the question is very simple if you know the formula. Here acceleration is given, amplitude is given A, and what is velocity of particle is half of the maximum velocity. So dear student, velocity of particle can be written as omega root A square minus x square. And what is maximum velocity? This is A omega. And in the question it is given velocity is equal to half of maximum velocity. If you simplify this relation, what you will get? Omega will get cancelled. Make the square. You will get A square minus x square equal to A square upon 4. If you solve this equation, you will find A square minus A square upon 4 equal to x square, means 3A square upon 4 equal to x square. After solving this relation, you will get x equal to what? Plus minus A root 3 upon 2. This is the general relation. Okay, so this is the position when velocity of particle will be half of the maximum velocity. This is the relation when velocity of the particle will be half of the maximum velocity. Okay, now let's see this question again. A particle executing SHM having amplitude 0.01 meter and frequency 60 hertz. Maximum acceleration of particle is, you know, acceleration of particle is written as minus omega square x. The minus sign indicates that direction of motion of the particle. Direction of acceleration always remains opposite to direction of displacement in SHM. Okay, and the maximum value of acceleration remains at the extreme position, that is equal to omega square a. That is equal to omega square a. Okay, so dear student, you can easily find maximum value of acceleration. This is equal to omega square a. And what is omega square? This is 2 pi f, means 4 pi square f square a. Now just substitute all these values, you can easily find. So for pi square is what? Pi square is approximately 10, and f is how much? This is 60 into 60. And what is amplitude? This is 0.01. If we simplify this relation, dear student, this 0 and 0 and this 0.01 will cancel. Okay, 4 6 into 6 36, 36 into 4 144, 144 into 10. Oh, this pi square equal 10, 6 into 6 36, 36 into 4 144. So here answer is in the term of pi square. Okay, so you can see your options. You have to see option in the exam also. The option 2 seems to be the correct answer, so we will write option 2. We will mark option 2 as correct answer. Okay, now dear student, let's see some more relation in SHM. If a particle is making SHM, if at displacement x1 from mean position, its velocity is v1. At displacement x2 from mean position, if its velocity is v2. We have to find amplitude and time period of the particle performing SHM. It is very simple now. See here, what is equation? v1 equal to omega root, because omega is same in SHM, a square minus x1 square, and v2 is what? v2 is omega root a square minus x2 square. If you solve these two equations, then you will find many relation. Okay, I am writing the relation. Time period will be equal to 2 pi under root x2 square minus x1 square upon v1 square minus v2 square. This will be the general relation of the time period. Okay, and this relation can give you omega also, 2 pi upon omega. Okay, and what is relation of amplitude? Amplitude can be found like this: x2 square v1 square minus x1 square v2 square upon v1 square minus v2 square, and maximum velocity is a omega. You can write maximum velocity is x2 square v1 square minus x1 square v2 square divided by x2 square minus x1 square. All these relation you can use to solve the problems. Okay, all these relation you can use to solve the problems. Okay, So dear student, this was the displacement, velocity and something. Let's see one more question. If a particle is moving from mean position, then equation in SHM is x equal to a sine omega t. Find the time when particle, find the time taken by the particle from mean position to x equal to a by 2, x equal to 0 to x equal to a by 2. We have to determine the time. This is very simple. Substitute the value of x equal to a by 2. This is equal to a sine omega t. Cancel a and a on both sides. You will get 1 upon 2 equal to sine omega t. 1 upon 2 is what? Sine 30 degree. Sine 30 degree is what? Sine pi by 6. So pi by 6 equal to what? Omega t. So what is time? Time equal to what? Pi upon 6 omega. And omega is what? 2 pi upon t. So this will be t upon 12. So this is the time taken by particle in SHM from mean position to x equal to a by 2. Okay, from mean position to x equal to a by 2. Hope you understood how to calculate time. You can calculate any time. Now, dear student, we will be looking for energy in SHM. Okay. The kinetic energy can be written as half mv square, and v is what? Omega root a square minus x square. So kinetic energy can be written as like this, and m omega square is SHM constant k. This can be expressed like this. Okay, so this is the general expression of kinetic energy. And how do we write potential energy in SHM? You can write like this: half kx square if we assume potential energy at mean position to be 0. Otherwise, write half kx square plus u 0. This is the general expression of potential energy. And dear student, in SHM, total energy, that is sum of kinetic energy and potential energy, remains constant. Okay. If you look at the general graph, at mean position kinetic energy is maximum. This is kinetic energy. At extreme position, potential energy is maximum. And if you want to find the position when total energy is equal to, if you want to find the position when kinetic energy will be equal to potential energy, it is very simple. Half k a square minus x square will be equal to half k x square. Okay, make k and k to be cancelled. Half half also cancel. If you solve this equation, you will get 2x square equal to a square. So x equal to what? Plus minus a upon root 2. This is the position when kinetic energy and potential energy is same. Okay, in SHM. Now, dear student, let's see this question. A particle is executing SHM from mean position at 5 centimeter distance acceleration is 20 centimeter per second square, then value of angular velocity will be very simple. Now see, a distance 5 centimeter from mean position, what is acceleration? Acceleration is given 20 centimeter per second square. Okay, so dear student, what is acceleration? Omega square x, this is equal to 20. So omega square into 5, this is 20. So what is omega square? This is 4. So what is omega? Omega equal to 2. This is 2 radian per second square. This is the value of omega. Okay. So out of 4 options, the correct answer is option 1. Option 1 is the correct answer. The maximum velocity of a harmonic oscillator is alpha and its maximum acceleration is beta. Its time period will be very simple. See, what is maximum velocity is given is alpha. What is maximum velocity? A omega, this is alpha. And maximum acceleration is given beta. What is maximum acceleration? Omega square A, this is beta. This is equation 1, this is equation 2. Divide these two equations, you get divide equation 2 with equation 1. You will get omega equal to what? Beta upon alpha. And what is omega? Omega is 2 pi upon t. So what is t? T is 2 pi alpha upon beta. T is 2 pi alpha upon beta. So answer to the given question is option 1. Answer to the given question is option 1. So option 1 is the correct answer. Okay, option 1 is the correct answer. If the maximum velocity of a particle in SHM is V0, you know maximum velocity remains at mean position, then its velocity at half the amplitude from mean position will be. Okay, very simple. You can use the relation V equal to omega root A square minus X square. Now use, what is V? V equal to V naught. This is maximum velocity, okay? And it is being asked V equal to omega root A square. What is X? X equal to half of the amplitude. So this is equal to omega root 3 by 4 A square. So you can write A omega A omega root 3 upon 2. And what is V A omega? A omega is V naught, okay? That is maximum velocity. So this is the answer to the question, okay? V naught root 3 divided by 2. So dear student, out of 4 options, the correct answer is option 4. So answer 4 is the correct answer. In the next lecture, we will see many more things in SHM. Okay, thank you.